Okay, this is Eric Glenwood back with you with more self-elevated EDF/spring power universal exoskeleton updates. Okay, I originally had the padded suit and I was wearing this exoskeleton over it, and I had started the new exoskeleton over it off to show you. I had blogged that I was gonna use this this utility vest that I had made, and I was gonna use it to basically wear over the new exoskeleton I'm working on, which is this right here. But I decided not to, because the thing is, see, I can put those pants on with those legs and those boots and have that vest on, and I can opt to either wear that utility vest, which I can put more plates in there for its ballistics. You can even buy raw AR 500 plates, steel plates. They still take the the AR rounds or the AK rounds, and I can actually cut them to shape and slide in the front and the back piece. In that backpack, it has a place where I can put a plate. In the front piece, that whole piece, I can run a plate to top to bottom. Now, like I said, I can either I can run this suit and have the legs and boots on, either run that upper extremity and arms or that tactical vest, and that's pretty good setup. And then for me to put it on the other exoskeleton, I would have had to modify that, and I didn't want to modify it since it fit this system so good. So other than that, I just decided to go another route with this one right here, and I did put the EDFs on the legs. And if you notice how somebody walks or sprint or run, once they pull a leg up, the back of their foot is facing rear, and that's why I put the EDF, so it's like pushing a leg forward as you walk. And then this 3, and it's like, excuse me, on the thigh, where it's just picking the thigh up every time you run. And then I've seen some systems to where they got the propulsion units on the back and the propulsion units on the hip, and they're trying to make a person go faster. They found that, hey, it'll give them a little bit more speed, but on some of them it's just actually racing up the device, and this is allowing them to move with like the device was not on them, but they was just using the jetpack. And then the thing is what of your body that creates that locomotion? That's what a lot of people are not realizing. They're just trying to push. And then some of the robotic exoskeletons and stuff are manipulating the legs, but they're manipulating the legs on sprint, trying to pick up heavy stuff, trying to elevate, carry heavy backpacks. I'm on this exoskeleton. I just wanted to be able to elevate the system, meaning that I can wear this system, have it on however much it weighs, that it's holding itself up. Other than that, I was still wanting to use human factors, using my own muscles, and then actually having light assist. That's why I have the light springs. So the springs, they're strong enough, the single spring itself, to hold the rest of this upper extremity up. Okay, and then also when I go in the squat or bend my knee, it actually gives me a little bit more kick up. Okay, other than that, the suit itself, I can move around and operate it without the EDFs on at all. That's why I just have the springs. I mean, my body, my knees. I mean, a 8-year-old can bend that spring with their knee. I mean, literally, they're not free, force a barrier on you like that. I'm put it like that. But other than that, but they still create assistance in the suit for your mobility. Okay, now you can actually get in a light sprint without running the EDFs on this suit, because I made it a lot lighter, this particular model here, with not putting all the heavy armorants on the boots. And I got it the anchor so it'll scrap your foot in the boot, so you manipulate the exoskeleton a lot better. Also, okay, now in the hints of you going to sprint, you need that extra little speed. It will give you that extra little speed. And when I was getting back to the other exoskeletons, to where like, we're not exoskeleton, like you got the Arizona State jetpack, and then you got Make It Real. They do some stuff, but they ain't random. They were just doing like skateboard tests, things like that. I just searched stuff that you know, some people that might look at might be familiar with, but in general, they were just pushing the body. They wasn't manipulating the actual thing that makes you run or gives you locomotion for us, the body, and that's the legs. That's why I opted to push the EDF, put the EDFs on the legs, and I have them pushing the EDFs, pushing you in a force to where your legs naturally push. When you go into a walk, your thigh naturally wants to raise up. Like when you go to run, your knee wants to raise up, your thigh wants to raise up. That's why I have the EDFs pushing your leg up. Okay, when you pull your foot up, like I said, your foot is facing back. That's why I have the EDFs right here on the back of the calves. So when you go in that motion and go to pull your knee up, it's actually like a swing. It's got like imagine like a pendulum or a swing with an electric motor on there and a fan, and it's pushing it in midair. All right. The other exoskeletons, when you talk about gear hydraulics, they, like, say if you raise your leg up, it'll manipulate the leg, right? Before it's the actual mechanics or motor function of it, it has to be contacting the ground to push you off. You understand what I'm saying? I mean, it needs that contact. It needs traction is what I'm getting at. Where EDF, it doesn't need traction. You can be walking on the ground regular and it's still pushing you. But once you go into a sprint and you go, like, to say jump over something, as you're in the air, the EDFs are still pushing you through the air. A hydraulic system or any gear system, I don't care how good it is, once you leave the ground, that system in effect is not giving you any forward locomotion at all anymore. That's what the EDFs are good for. Once you go on a run, say when you're trying to clear like say a trench, you're trying to jump over, it's 4 foot wide, 8 foot wide, depending on how much you weigh, you might not be able to clear it, right? But if you got that extra push, and like I said, when you get up in the midair, those fans are still pushing you across the obstacle, where opposed a hydraulic or a gear system, however much energy you build up, once you leave that ground, you can't put any more energy into that suit. You can't put any more forward locomotion into that suit in midair using hydraulics or gears. You can't do that in EDFs. Like with an airplane pushes, like an airplane motor pushes the airfoil or the plane through the air and allows the wings to catch air and make effect. That's what gives flight. So that's something that a lot of people are not thinking of for is that when you come to force locomotion, when you come to a human body. Also, a lot of people don't realize, and you can research this if you want, when you're running or even when you're just walking, it's a scientific fact that 70 to 80, depending on the person and how big they are and how much wind resistance they create, 80% of your energy is used overcoming wind, literally air. Just like when you wouldn't think of it, but just like a fish swimming through water and using the water, or like a jet engine uses the water pressure through it's like on a jet ski, it's got like a water jet, and it uses the pressure of the water and the displacement of that fluid to move it along. Air has thickness just like water has thickness. Like if you want to equivalent to it, let's say like a honeybee when it's moving its wings so fast that if you would put equate a honeybee to how its effects on the wind and how it's dragging through the wind, they say it's like literally getting a spoon and turning it through honey. Like you yourself getting a spoon and turning it through honey. So wind does have thickness. Okay, the air around you has thickness and pressure too, depending on, like, helicopters work better and aircraft work better at sea level opposed to the high altitude around mountains and things like that because the air is thinner. You're on the ocean level, you might have 13 psi air pressure around you, but when you get on some mountains, you go all the way down to 8, 7 psi for it's the air pressure around you. That's why they need oxygen to breathe on top of mountains. Things of that nature. So air does have thickness. And like I said, if you research, 80% of your energy used in walking or running is overcoming the drag of air. I'm using air to actually push me. And then, like I said, for it's running, jumping, clearing obstacles, air still pushes you. Opposed to hydraulics and gears, like I said, once you leave the ground, they're not giving you any mobility.